All right, this is going to be geometry. We're going over the Unit 3 pretest. All right, so let's talk about number 1. And everyone is copying down exactly the work that I do, more or less. Okay, so yeah, exactly. You don't have to copy down the problem, you just have to copy down the work. The length of the hypotenuse. This is Pythagorean theorem. That's a squared plus b squared is equal to c squared.
I have one question.
Yes.
Do we have to do this Cornell note style, or can we just write 1 and then 2?
You don't have to do Cornell note style, no. All right, I know my a and b. My a and b are 6 and 8. So it's 6 squared plus 8 squared. And I don't know c. I'll leave that c squared. All right, 6 squared, shout it out.
36.
So 36 plus 8 squared, shout it out. 64 is equal to c squared. 36 plus 64 is 100. Therefore, c is equal to 10. Answer is B. All right, what is the value of x in the triangle? Again, this is Pythagorean theorem. So I'm going to actually write out a squared plus b squared equals c squared again. A squared plus b squared is equal to c squared. That means my x, I'm subbing in x for a, I'm going to say that was a, this is b, this is c. So x squared plus 12 squared is equal to 13 squared. All right, so I have my x squared plus 12 squared, shout it out. 13 squared, shout it out.
169.
Ah, there it is, 169. What's 14 squared? 196. All right. 14 squared, you switch the digits of 13 squared. If you memorize 13 squared, you can memorize 14 squared. All right, so I'm going to subtract 144 from both sides, and x squared is going to equal 25. Therefore, x is equal to 5 after I square root both sides. X is equal to 5. Number 2 is C. Please do stop me if I'm going too fast. Stop me if you have questions. Stop me if you have any concerns. I'm concerned, Mr. Sandell. I got that one right. You marked me wrong. How dare you? All right.
It's funny, I got that one right, but the first one I didn't get right.
Wait, can you go back to the slide, please?
Yes.
Okay, thank you.
All right. Moving on to number 3. A right triangle's hypotenuse has a length of 5. So let's draw that right triangle. You are drawing the right triangle with me. The right triangle's hypotenuse has a length of 5. If one leg has a length of 2, what is the length of the other leg? So it looks like this. All right, so from here, set up our Pythagorean theorem. A squared plus b squared is equal to c squared. We know our a. I'm going to say that this is our a, this is our b, this is our c. Therefore, a is going to be 2 squared plus, we don't know our x squared. And we know our hypotenuse squared, that's going to be our 5 squared. 2 squared, shout it out. 4 plus x squared. 5 squared, shout it out. 25. Therefore, x squared is equal to 21. Therefore, x, if I square root both sides, I am left with the square root of 21. And the correct answer is b, square root of 21. And that can't be reduced. There's no perfect squares in 21. Number 4. Each set of numbers below is the measurements of a side of a triangle. What is a right, or which one of these is a right triangle? How do I test for a right triangle? Does anyone remember? A squared plus b squared equals c squared, something using that. If I plug in the two smaller values, 2 and 3, into a and b, or if I just plug the larger value into c and then just a and b can be anything, these two sides need to equal each other, and if they do equal each other, it's a right triangle. So let's plug in 2, 3, and 4. If I plug in 2, 3, and 4, so 2 squared plus 3 squared is equal to 4 squared. Is that true? Is this in fact equal? Well, 2 squared is, shout it out, 3 squared, 4 squared, 16. Does 4 plus 9 equal 16? So it cannot be A. Let's try B. So 4, 6, and 8. So 4 squared plus 6 squared should equal 8 squared. All right, 4 squared, shout it out. 6 squared. 8 squared.
64.
All right, so when I add these up, I get 52 equals 64. That doesn't work either. Can't be B. Let's try C. 7 squared plus 7 squared equals 10 squared. 7 squared is 49 plus 49 equals 100. That doesn't work either. This is, it's going to be 98 is equal to 100. Really close, but not quite. Can't be C. And by process of elimination, it is D. Do you want to see what the correct answer looks like? Oh,
I got that right.
I got
But
that
you
right
marked
too.
it wrong.
Oh, shoot. Okay. Yeah, that's an error in the key. All right, so I'm guessing. Yeah, okay, so I'll go ahead and fix that in all of our tests. Sorry about that. The correct answer is D. All right.
I was like,
Yeah. It was
Eva, on the board, can you write number 4? Just a giant 4 on the board. That will remind me to go correct number 4 for geometry. All right, number 5. This was the hardest, I think, the hardest problem on the entire test.
wait, but it's wrong.
All right, let's go through number 5. We have this pipeline, and its oil flow is going around here. The plan showing the old pipeline and the new route is shown below. Old pipeline and new pipeline. About how many extra miles will the oil flow once the new route is established? All right, so what is the new pipeline goes 60 and 32. So the new pipeline goes 60 plus 32, and that is equal to 92. But it's how many extra miles? So we need to figure out what the old pipeline is. So we have to find the old, and that's using Pythagorean theorem. So I have 60 squared plus 32 squared is equal to x squared. And that is a hard problem. I can show you guys a trick which doesn't simplify it that much, but it does help you out a little bit. Or we can just do this problem. So the trick for this problem is setting up a proportional triangle. All right, so I can divide everything by 2, and I can get 30 and 16. I can divide the triangle by 2 again. Because you see the 60 and 32? Half of 32 is 16. So if I divide by 2 again, I get 8 and 15. So that means to get from this triangle to this triangle, and you can just, since you don't have the original triangle, you can just say, I have to multiply by 4 to get that triangle. You can write it maybe inside of that triangle. If I multiply this triangle by 4, I get the original triangle. So just remember, I need to multiply by 4 at the very end, but I can do Pythagorean theorem on this triangle, 8 and 15. All right. So using Pythagorean theorem, now it's a little bit easier. It's going to be, I have to multiply everything by 4, so I'll keep that as a reminder, but it's going to be 8 squared plus 15 squared is equal to x squared. So 64 plus 15 squared, do we know that one?
Wait, hold
225.
225, yeah.
You got it.
225 is equal to x squared. So adding these up, I get 289 equals x squared. Does anyone know what squared gives you 289? Looking at the wall. There it is, yeah, 17 is equal to x squared. Not x squared. Okay, so if that is 17, remember I have to multiply that by 4 in order to get to the hypotenuse. This was 17, I agree, but this whole triangle needs to be scaled up by a factor of 4 to get to this triangle. So 17 times 4, that's going to be 68. So this old pipeline is 68. So this is, I guess, an inefficient pipeline because the new pipeline adds on more, but it goes 68, where the old, or the new pipeline goes 92. 92 minus 68 is equal to 24. It flows 24 extra miles because the old pipeline was 68, the new pipeline is 92. There's a lot that just happened in that problem. The trick for this problem was scaling down the triangle. The hard thing about this problem is to understand what the problem was even asking for. How many extra miles will it flow?
I have a question.
Yes.
How do you got A in 15? I just didn't get
How'd I get what?
A in 15. Why do you multiply that?
8 and 15? Oh, so 8 and 15 came from this triangle right here, 8 and 15. So I had 60 and 32, and I divided by 2. And I get 30 and 16. I divided by 2 again to try to scale down the problem as much as possible, and I got 8 and 15. Once that problem is scaled down, then I can plug those into Pythagorean theorem, remembering that I need to scale up by a factor of 4 to get to the original problem.
Okay, I got it.
If I had a calculator, I wouldn't have to do this, though. All right. Questions on number 5? It was a really hard one. I think only one person got it correct. All right. Let's go to number 6. So these problems were missed pretty frequently, too, but not as much as number 5. So in the figure above, what is the measure of x? So this is a 45, 45, 90 triangle. I can just mark it like that. That's 45, 45, 90. So if this length here is x, this length is 6. In order to get to x, I need to multiply by square root of 2. The correct answer is 6 square root of 2. Remember, the original 45, 45, 90 is x square root, or x square root of 2. All right, let's look at number 7. In the figure above, what is the measure of x? All right, so I have a 30, 60, 90. Remember the original 30, 60, 90. Oh gosh, my triangle can't be better here. Oh gosh. My 30, 60, 90 has x, 2x, and x square root of 3. Square root of 3 goes on the leg, not the hypotenuse. So if this is 6 square root of 3, I need to divide by square root of 3 to get to here. If I divide by the square root of 3, the square root of 3 cancels out. I'm left with just 6 here. And then to get to the hypotenuse, I need to multiply by 2, and I get 12. So in this problem, I divide by square root of 3 and multiply by 2. Does everyone remember that 6 square root of 3, if you divide that by square root of 3, these cancel out? You remember this rule? All right, just making sure. All right, do we need more time to copy this down? All right. Would anyone like this to be explained again? All right, moving on to the next problem. Number 8. This one was probably the most missed in this page, between number 6 and 10. All right, so in the figure above, AB, so this length here is square root of 2. Square root of 2. What is the length of BC? What is the length of that segment? All right, well, this triangle I have a 45, 45, 90. So if this was 1 square root of 2, you can multiply anything by 1. In order to get to the leg, I need to divide by square root of 2. And if you're having trouble remembering that, here's my 45, 45, 90. This is x square root of 2, and this is going to be my x. In order to get from here to here, I need to divide by square root of 2. So square root of 2 divided by square root of 2 gives you this length here is 1. Now I have a 30, 60, 90. I'll redraw this triangle, 30, 60, 90, where this is the length of 1. In order to get to the hypotenuse, I multiply by 2 because, and just redrawing the general 30, 60, 90, this is going to be x square root of 3 and 2x. So I need to multiply by 2 to get to the hypotenuse, and the length of x is 2. All right, no one has questions? All right, moving on to number 9. What is the value of x in the triangle below? So this was kind of a hard problem too. So again, this is my 45, 45, 90. So x, this is x root 2. So if this is x root 2, you can think of this thing as x square root of 2. In order to get to x, I need to divide by the square root of 2. So I have 10 divided by the square root of 2. and this is something that you definitely need to write in your notes, 10 divided by square root of 2, I need to multiply this by square root of 2 over square root of 2. This problem turns into square root of 2 times square root of 2. Get rid of that denominator, or get rid of that square root in the denominator first. Square root of 2 times square root of 2 is 2. And I leave the top. The top always stays the same. So 10 square root of 2. Once I have 10 square root of 2 over 2, I can simplify. What is 10 divided by 2? There it is. Thank you. Yeah, 5 square root of 2. Correct answer is B, 5 square root of 2. All right, going to number 10. If you want to shout out, go back to the previous slide, go for it. Do you need the previous slide, Steph? Okay. All right, moving on to number 10. So A is equal to 3 square root of 3. So we're going to say this is 3 square root of 3. What is the value of B? All right, so if I do my 30, 60, 90 triangle drawn the same way that is represented here, if this was x, this would be 2x, this would be x square root of 3. So in order to move from A to B, remember we're trying to find B, in order to move from A to B, the operation is multiply by square root of 3, because this one says multiply by square root of 3. So maybe I should do my multiply times square root of 3. So I need to multiply by square root of 3 here. So the question becomes, what is 3 square root of 3, all of this times square root of 3? And this is just multiplying radicals. Square root of 3 times square root of 3 is 3, because this is the same thing. I'll write this out really slowly. 3 times square root of 3 quantity squared. There are 2 of these square roots of 3's. Square root of 3 times square root of 3, square root of 3 squared. The squared and square root cancel each other out, and I'm left with 3 times 3. The correct answer is 9. All right, that was number 10. I still see pencils writing. Make sure that you're looking at your test, number 10. So get ready to look at number 11 on your pretest. All right, let's go to number 11. Most people got this page pretty, I'm not saying everyone got it, all of them correct, but this one had a higher percentage on average. So in the figure below, if sine of x is equal to 15 over 13, what are the cosine and tangent of that x? So sine is opposite over hypotenuse for katoa. So opposite is over here. This is opposite. This is hypotenuse. So this means this is 5 and this is 13. So I need to figure out what this remaining leg is. So go ahead and draw this triangle, 13 and 5. And I need to also solve. So I'm going to do x squared plus 5 squared is equal to 13 squared. All right, x squared, 5 squared, shout it out. 25. 13 squared, shout it out. Not Steph, she got it last time. Yeah, 169. Perfect. Then from here, I'm going to subtract 25 from both sides. I'm going to get x squared is equal to 144. Therefore, x is equal to 12. So I can say this side is 12. All right, so cosine of this angle. Cosine of this angle is, I should write this out, katoa. So cosine is adjacent over hypotenuse. This is the adjacent over hypotenuse. is 12 over 13, so C and D are eliminated. 12 and 13, 12 over 13 is correct for cosine. And then tangent. Tangent is opposite over adjacent. Opposite over adjacent is 5 over 12. So correct answer is A. All right. And Eva, can you shut the door for us, please? You can bring the doorstop and place it by the trash can. That works. Thank you. All right, number 12. Measure of angle A is 32 and AC equals 10. Which of the equation is used to find x? All right, so this is going to be, if this is my angle, this is going to be opposite and adjacent. Coming up to SOHCAHTOA, opposite and adjacent is tangent. So which one of these has tan? That's a sine, that's a cosine. Oh, there's a tangent. Oh, that's a cosine. Process of elimination, it has to be C, just because it's tangent. We don't even need to set up the problem. Tangent is opposite over adjacent. If you want to actually know how to get this problem, I can do that really quick. So you can say tangent of 32 is equal to x over 10 and multiply both sides by 10. If I multiply both sides by 10, x is left alone, and I get 10 times tangent of 32. All right, and I'll wait for the pencils to stop writing. Steph, you good? Okay. Number 13. In the figure below, sine of A is equal to 0.7. What is the length of AC? All right, so if we're asking for AC, this length here, I'm going to say that that length is x. So go ahead and draw this triangle where you have A, B, C, 21 is BC, and AC is x because we're trying to find AC. All right, so I need to figure out what trig function is used for the opposite and the hypotenuse. Hopefully you remember that that is sine. Sine of my angle, so I'm going to say some angle, we'll say theta. Sine of some angle, this angle, is equal to 21 over x. 21 over x. But I know what sine of that angle is. Technically, I should have put sine of A. That is, this whole thing right here, sine of theta, is 0.7. So I can say 0.7 is equal to 21 over x. And from there, I can cross multiply, because that's 0.7 over 1. I cross multiply and I get 0.7x is equal to 21. That came from cross multiplying. So it's 0.7 times x and 21 times 1. And I can do my little symbol like this. All right. Now I need to divide both sides by 0.7, and I get x is equal to 21 over 0.7. And the trick for dividing by decimals is to get rid of the decimals. So that is the same thing as, let's multiply the top and bottom by 10. This is going to be 210 divided by 7. Oh, well, I see 21 and 7 now. So this is the same thing as, I'm running out of room here. This is the same thing as 21 times 10 over 7. 21 divided by 7 is 3. So this whole thing turns into 3 times 10. Because 21 divided by 7 was 3. 3 times 10, correct answer is C, 30. All right. Number 14. Which equation should be used to find? So go ahead and just write this triangle in your notes. And we're trying to find JK. JK is this length right here. Maybe we should just label that JK. This thing right here, JK. How do we find that? Well, I go opposite of the angle, so this is my opposite, and this is the hypotenuse. So what trig function uses opposite and hypotenuse? And it is sine. So it can't be cosine. So sine of 24, and it's going to be opposite over hypotenuse. This one is opposite over hypotenuse. Write whatever notes you'd like for this problem, especially if you missed it. All right. Number 14 is good. Let's go to number 15. The diagram shows an 8-foot ladder. All right, go ahead and draw this triangle in our notes. So which is closest to the distance up the wall? So this is our measurement that we're trying to find. All right, so in terms of our wall, or in terms of this angle, this is our angle of reference, or our reference angle. Is this going to be the opposite, adjacent, or hypotenuse for the question mark? Shout it out. Adjacent. And obviously this is our hypotenuse, it's the diagonal. So we need to find a trig function that uses adjacent and hypotenuse.
Cosine.
And it is cosine. So we should be using this value here. So you can write down cosine of 53 equals 0.6 in your notes. And then I also need to set up my relationship. I can say that cosine of that angle, 53, is equal to, and it's adjacent over hypotenuse, so it's that question mark, I'll just call that x, all over 8. Which means when I cross multiply, I get x just by itself, because it's x times 1, equals 8 times cosine of 53. Well, cosine of 53 is 0.6, so this is really the same thing as 8 times 0.6. So when you multiply decimals, remember to move the correct number of decimal places over. So when we multiply 8 and 6, remember to move the decimal place 1 to the left. 6 times 8 is 48. 48. And we need to move the decimal place 1 to the left. 1 to the left, 4.8 is the correct answer. Can you guys give me a fist of 5? How comfortable are we multiplying and dividing decimals? 5 is, I got all of them right on the test, Mr. Sindel. I have proven I know how to do it. You can give me a 4 or 3 if you missed 1 or 2. All right, I'm getting 4s and 5s. Perfect. Let's go to number 16. The Pythagorean theorem. Almost everyone got these correct. So 6 and 8. So I have 6 squared plus 8 squared is equal to x squared. Call them out really quick. 6 squared is 8 squared. That's equal to x squared. Therefore, 100 is equal to x squared. Therefore, x is equal to 10. Even if you got it correct, you're writing this in your notes. Number 17. This one was, the one person that missed this one, I think, mixed up that this was the leg. So this is a leg and a leg. The two sides that are opposite of the 90-degree angle should be the A and B. So A and B are opposite of the 90-degree angle. They should touch that 90-degree angle. That's another way to think about it. So I have x squared plus 5 squared is equal to 13 squared. X squared plus 25 is equal to, okay, someone new. Who hasn't done 13 squared yet? There it is. Eva has 169. Subtract 25 from both sides. I get 144. Therefore, x is equal to 12. All right, number 18 was the hardest out of the 3 because it's not a perfect right triangle, or it is a right triangle, but this number is not an integer. All right, so let's do this problem. I have a leg, x squared, plus another leg, 7 squared, should equal 11 squared. All right. X squared plus 7 squared, shout it out. 49. 11 squared, shout it out. Perfect. And I get x squared is equal to, if I subtract 49 from both sides, I get 72. I think one person made a subtraction error and got 71. All right, so from here I just square root both sides and I'm left with x is equal to the square root of 72. And if you got that much, I would give you full credit, but that's not the simplified answer that I want. Because 72 is really, and I can write this down here because I'm running out of room, but square root of 72, this is the same thing as the square root of 36 times the square root of 2. 36 times 2 is 72, and therefore this problem is, square root of 36 is, shout it out, 6, yes, 6 square root of 2. 6 square root of 2 was the answer I was looking for. All right, moving on to problem 19. Oh, whoops, looks like pencils were still writing. All right, moving on to the next slide unless someone raises their hand. All right, here we go. Number 19. So this is a yes or no, is it a right triangle? All right, this is again the converse of Pythagorean theorem, so I have to do 2 squared plus 3 squared equals 4 squared. If both sides are equal, it is a right triangle. 4 plus 9 equals 16. I think this was the same problem from a previous problem too. So this is 13 is equal to 16. That is a no. Those are not the same. All right, for number 20, the trick again for number 20 is you can reduce the triangle. Remember, if it's scaled, that's just a similar triangle. Similar triangles have congruent angles. So I can scale this down and do this problem. Let's try to rewrite the problem. So this is 12, 5, and 13. If I scale the problem, it should still work because, as I said, similar triangles have congruent angles. All of these angles, and this one should match this one because I just scaled it down. So I should have 5 squared plus 12 squared. The two smallest numbers should add up to equal the biggest number squared. So this is 25 plus 12 squared, shout it out. 13 squared, shout it out. All right. And this is 169 equals 169. We didn't even have to do these big numbers because we can scale it down, and this is a yes. If you don't like the numbers in a triangle, scale it down. Use that Unit 2 knowledge. All right. Looks like pencils have stopped writing. Nope, there's one pencil still going. All right, going on number 21. All right, determine each missing side. This one was missed. All 3 of these were missed more than I would like, so I'm going to spend a little bit more time talking about these. We have, what do we have? 13 minutes left of class. So this is a 30, 60, 90. Maybe I should draw a general, not a 30. This is 45, 45, 90. So a 45, 45, 90 generally is x, x, x square root of 2. And a 30, 60, 90, we'll get that one. Oh wait, we don't need that one yet. Scratch that. Make sure you have your general 30 or 45, 45, 90 triangle on your paper. So if this is x, then this is also x. This also needs to be 6. If this is 12, I need to multiply by square root of 2. To get from x to x square root of 2, I need to multiply, I should say, times square root of 2. So this should be 12 square root of 2. So to get to here, multiply by square root of 2. All right, number 23. Now I'm going from this hypotenuse and I'm going over here. I have to divide by square root of 2. So I need to go from here to here. I need to divide by square root of 2. So the question becomes, well, what is 22 divided by square root of 2? Make sure that you definitely have this part in your notes. 22 divided by square root of 2. This has been messed up quite a few times by a lot of people. I need to multiply the top and bottom by what number? Shout it out. Yeah, square root of 2. That will get rid of the radical in the denominator. I'm going to pause here. Make sure everyone gets caught up to this point so they can think about the problem. Okay, we need to ask ourselves, what is the top, what is the bottom, now that I have multiplied by square root of 2? Let's try the harder one, the bottom. What is the bottom going to be? Shout it out. 2. The top is going to just stay that 22 square root of 2. So our final answer is what? Shout it out. 11 square root of 2. Perfect. Because I simplify the 22 and the 2. All right, let's move on to number 24. Determine each missing side. The general 30, 60, 90, write this in your notes. We've written it over and over again. Is x. The hypotenuse is going to be what? If the shortest leg is x, the hypotenuse is 2x, yes. And therefore, the remaining leg is close. Something with a 3.
X to square root of 3.
Yeah, x square root of 3. Perfect. All right, so in this problem, I'm moving from the shortest leg to the hypotenuse. So going from here to here, that is going from x to 2x. That means I need to multiply by 2. 7 times 2, and I get 14. All right, number 25. I'm going from the hypotenuse to the longest leg, and that's kind of hard to do. So what I'm going to do instead is I'm going to go from the hypotenuse to the shortest leg, and from the shortest leg to the longest leg. So from the hypotenuse to the shortest leg, that's 2x to x. I am dividing by 2. So 8 divided by 2, and I get 4. So once I have that shortest leg of 4, once I have that shortest leg of x, I need to get to the longest leg by multiplying by square root of 3. So times square root of 3. And my final answer is 4 radical 3, or 4 square root of 3. It's the same way of pronouncing it. All right. Number 26. I have the longest leg, and I'm trying to get to the shortest leg. From the longest leg to the shortest leg, I need to go and divide by square root of 3. To get from x square root of 3 to x, I need to get rid of that square root of 3 by dividing it. So this is going to be
13.
divided by square root of 3. And those square roots of 3's will cancel out, and Geo has it. It's going to be 13.
I don't know why I guess it was only 39.
All right. Let's do number 27. Everyone basically got this one right. One person made a dumb error. But I think you know what's going on. It's sine of b from this angle. So sine of b. So go ahead and write this triangle in your notes and say sine of b is equal to. So sine is going to be opposite over hypotenuse. That's going to be 15 over 17. Cosine of b. That's going to be adjacent over hypotenuse. That's going to be 8 over 17. And tangent of b. That's going to be opposite over adjacent. It's going to be 15 over 8. That one should go really fast. Almost everyone got this one correct. Even the person that made a mistake still knew what they were talking about. They just did sine of a, cosine of a, and tangent of a. All right, going on to number 30. All right, 30 through 33, or 30 through 35, these were really commonly missed questions. So I'm going to spend the rest of the class on these. Obviously, we have 7 more minutes left of class. All right, so sine of 32, for this one, we didn't need to do anything where we had to substitute something in for sine of 32. You leave it as sine of 32. So I need to cross multiply. So that's going to be x times 1 is just x, and 25 times sine of 32, 25 times sine of 32. That is the correct answer. So in the notes, I'd like you to write the problem and write how to solve it. So if you've already finished writing number 30, start copying down problem 31. Number 31, you've copied down problem 31, and 31 you're going to divide by 1 and cross multiply. Okay, let's change colors here to cross multiply. Oops. So cross multiply, and I get x cosine of 61 is equal to 13. Divide both sides by cosine of 61, and x is equal to 13 divided by cosine of 61. All right. Number 32, I think, was missed by basically everyone. So be really careful on 32. That's our 5-minute warning. Number 32. Copy down 32 and get ready to pay attention. All right, so the first step, again, is to cross multiply. So if I cross multiply, I guess this is technically tan of 17 divided by 1. If I cross multiply, I'm left with x plus 2 times 1 is still x plus 2 is going to equal 5 times the tangent of 17. Most people got that correct. Here is the error. When you subtract both sides by 2, because I just have to isolate for x, when I subtract by 2, minus 2, minus 2, this whole thing is still being multiplied. I can't do 5 minus 2 to get 3. The correct answer here is just x is equal to 5 tangent of 17 minus 2. You leave that minus 2 because you can't subtract the 2 from the 5. So be very careful when you have problems where you have a variable adding something in the numerator or denominator. All right. I'm going to problem number 33. All right, for these ones, we have to set up our trig function and then solve. So setting up our trig function, if this is our reference angle, Aurelio, stop.
Yeah, he took my phone, so. Where's it?
All right, number 33. My trig function is going to be opposite and adjacent, so this is going to be tangent. So I can say tangent of 35. I just want you to write down the trig expression. You don't need to write down the triangle for the notes. Tangent of 35 is equal to x over 10. Multiply both sides by 10, and x is equal to 10 times, and I'm not going to write tangent of 35. I'm going to take that out. So tangent of 35 was 0.7, so 0.7. And when I multiply by 10, the rule is I just move the decimal place 1 to the right. So x is equal to 7. All right. Going on to 34. You don't need to write the triangle. You just need to write out the proportion. So if this is my reference angle 40, this is my opposite. This is my hypotenuse. Therefore, opposite and hypotenuse is sine. So, for SOHCAHTOA. So sine of 40 is equal to opposite over hypotenuse. So this is going to be 12 over x. I'm going to cross multiply. Cross multiply these. And I get x times, I'm not going to write sine of 40. I know what sine of 40 is. Sine of 40 is 0.6. 0.6 is equal to 12. From there, I need to divide both sides by 0.6, so x is going to equal 12 divided by 0.6. A lot of people got got to here, 12 divided by 0.6, I would say 2 or 3 of us got here, and then they didn't do this operation correct. So I'm going to show you the quick and easy way to divide by decimals. Get rid of the decimal by multiplying the top and bottom by 10. This is going to be 120 over 6. And then 120 divided by 6, you can think of this, oh, well, I see a 12 and a 6, so that's the same thing as 12 times 10 over 6. 12 divided by 6 is 2, so this is really 2 times 10, or 20.
So that's just
So the answer here is 20. All right, number 35 was really hard, and we have 30 seconds left of class, so I'm going to go through this kind of quick. So I have tangent, because this is opposite and adjacent, so tangent of 35, or tangent of 75, is equal to 17 over x. I cross multiply, I get x times tangent of 35, or tangent of 75, I don't know why I keep saying that, is 3.7. So 3.7. That is going to be equal to 17. So my correct, and you can even leave your answer kind of like this. I would have given you most of your points. X is equal to 17 divided by 3.5. The full and correct answer, I don't like denominators to have decimals, is x is equal to 170 divided by 35. Just multiplying the top and bottom by 10. If you wrote 170 by 35, that's fine.
it's not 3.5, it's 3.7.
Oh, 3.7, sorry. Thank you. Come on, eraser, work. There it goes. Yeah, so this is going to be 37. 3.7 there and 37 there. All right. So that was the final answer. You didn't have to change that into a decimal. You didn't have to do long division. A fraction is fine. All right, that concludes the pretest solutions.